Hey everybody, welcome back from spring break. Hope your break was wonderful and your day's going well so far. In math, the next 2 weeks, we're going to be spending time getting ready for MCAs. And the nice thing about MCAs for math is we don't go into freak out mode or get really anxious or excited because there's nothing new that we really have to teach you before MCAs. Everything that's going to be in the MCAs we've been learning all year. And so we stop over these next 2 weeks and just take some time to catch our breath and make sure that we have understood everything we've learned so far, and we take about 4 review days to go through these they're called strands. And so today the strand is called number sense. So like typical in this flip video, I'm going to ask that you take notes right along with me. If we get going too quick, just raise your hand, ask the sub to pause it, and we can catch up. But my hope is that most of this day today for you is a lot of time where you go, oh yeah, I remember learning that. A lot of this stuff even goes back to 6th grade. So we'll take some notes. This is a mini lesson, so it'll be probably a little bit shorter than most lessons. And here we go. So this is called number sense. So draw that up at the top of your paper there. And as it sounds like, it's just how numbers work. And so we'll start with the most basic things like types of numbers and then evolve into a little bit more advanced things. So the first thing I want to review with you is actually a vocab word, or a couple of vocab words that we talked about at the way beginning of the year. And the first word I want you to write down is the word integer. Not a word that we use a whole lot outside of math class, but an integer, remember, is a whole number. And it's different than just calling a number a whole number because integers are whole numbers that are positive or negative. So positive. And there's actually one more number that's considered an integer. It's not positive or negative. Wonder what that number would be. 0. So it includes every single whole number, positive, negative, or 0. And if we make a list of them all, it goes forever in the negative direction. I'm just going to do -2, -1. There's our 0, 1, 2, and then forever in the positive direction. So there are an infinite amount of integers. Any whole number, right? No decimals, no fractions, just plain old integers. So that's first definition. The second one is rational numbers. Slide that down. The word rational in math helps to look kind of at its root word, which is ratio. So this is any number that can be written as a ratio. And the better way to say that, remember, a ratio is just a fraction. So a rational number is any number that can be written as a fraction. Because ratios and fractions are the same thing. Now, if you think about this, this includes all fractions. Whoops. Because, of course, fractions can be written as fractions. This would be positive 1/2, negative 3/4, and we can list a whole bunch more. But every single fraction is a rational number. Now, if you think about it, all whole numbers are also rational, positive or negative, because you can always write a whole number as a fraction. For example, 5 is really just 5/1. So every single whole number is a fraction. That also includes 0. Even though 0 is technically not a whole number, we can group it in there. So we got every single fraction, we got every single whole number. And then the other category, I'm going to have you write some decimals, because it's not all decimals, but some decimals are rational numbers. So you got things like 0.5, which is 1/2. You got things like 0.3 repeating, even though that repeats forever, because that's 1/3. You got like 0.36, because that would be 36/100, and then we could reduce it down. Decimals that aren't rational are called irrational numbers. Those are numbers that go on forever without a pattern, like your pi or your square roots of numbers like that. But those are 2 big ones right now, rationals and integers. So I'm going to slide this down here. I want you to take some time here we're going to pause the video in a second. You're going to write down 3 integers, and you're going to write down 3 rational numbers. You may not use any of the numbers that we've already put down in our notes. I want you to come up with 3 new ones. So I'm going to have the video be paused. You take some time, team up with your table partner there, write down 3 integers and 3 rationals. Here's mine. I doubt you put mine down because there's a whole bunch of different choices. But my integers, I did 43, 7, 36, 3 numbers of my favorite Pittsburgh Steelers, Troy Polamalu, Ben Roethlisberger, Jerome Bettis. Rationals, I just did a couple decimals. I did 0.65, I did 1.16. Because they're terminal, it means they stop. Those are rational numbers. And then I threw a fraction in there, -3/2. So, so just a quick little thing, and you'll see these kind of on your practice rationals and integers. Next little heading, change of subject here, scientific notation. Scientific notation is something we talked about in chapter 1, and I think it was chapter 3. It's come up a couple times this year. But remember that scientific notation is a shortcut, like shortcuts in math, and it's a shortcut for writing really big or really small numbers. So really big or small numbers. If it hasn't popped up in science yet this year, I think it does later on, and definitely next year in 8th grade science. But the format for scientific notation is a number times the number 10 to a power. And there's rules about this lead number, or the leading coefficient of scientific notation, and it must be between 1 and 10. It could be a decimal, and a lot of times it is. It's got to be between 1 and 10. The other arrow I want you to draw to is the power. Make this kind of a little 2-pronged arrow that comes off a power. If you remember, it's been a while, but if you remember, if that number is a positive power, that automatically tells you it's a very large number. And if that number is a negative power, that's one of those small numbers. I'll show you an example of each one just to kind of recreate and bring scientific notation back. But that right there, that's a biggie. That's our format for scientific notation. I know MCA loves scientific notation. You definitely see a little bit of scientific notation on there. So let's look at how this one works. So if I've got 54 million, for example, 54 million. We'd have to look at this and go, you know, it's a big number. It's not huge, but it's a big number. And the shortcut for writing this in scientific notation is to find the number between 1 and 10. When your repeating zeros start, that's your cue to kind of find this number. So I got 54. The best way to do that is 5.4. Only way to do it is 5.4. So I'd say 5.4 times 10. And then we do some swooping. Put your decimal up here, and we swoop to the end. 1, 2, 3, 4, 5, 6, 7 times to the end. So that 7 is the power of 10. So 5.4 times 10 to the 7th power. On the other hand, if I've got a little number, let's go 0.0000, 4 zeros, 1, 3, 9. Little number, same task. You have to look and find a number between 1 and 10 out of this guy. Start at the end, and you work your way back. 139, too big. 13.9, too big. 1.39, just right. So 1.39, because it's between 1 and 10, times 10. And now you do your same trick. Put your decimal right at the 1.39, just like you put it right up here in between the 5 and the 4. Now we're swooping left. 1, 2, 3, 4, 5. But because we swooped left, that's the negative direction. So 1.39 times 10 to the negative 5th power. So one example of the big, one example of the small. Let's see how we're doing on these. And by the way, the other way, actually, before we see how we're doing on these, the other one to do is to say, can you write something in scientific notation? So if I say, what's 1.21 times 10 to the 6th power? And give you something that's in scientific notation, and you have to write it in what we call standard notation, or just decimal notation. You drop down your 121, look up at your at your exponent. It's a positive 6. That says swoop right 6 times. So I'd go 1, 2, 3, 4, 5, 6. And what do I put in those slots? That's correct, zeros. So you drop your zeros in, 0, 0, 0, 0. And the final thing that you do to write that number fully is put some commas in. So I'd go 3 from the end, comma, So that'd be 1,210,000. Similarly, if I've got a number, let's say 4.27 times 10 to the negative third power, and that's in scientific notation, kind of like this one ended up. Put that in decimal notation. I'd go 427. I'm writing it more to the right side of my paper because I know that's a negative, and I'm going to have to swoop left. Left 3 times, in fact. So 1, 2, 3. And into those 2 spots go zeros. 0, 0. Done. So I'm going to have you try some of these. I'm going to give you 2 numbers. I want you to write the first one in scientific notation. I want you to write the second one in decimal notation. So we'll call this one A, and I'm going to have you write 1,360,000,000. Write that in scientific notation, and then for problem B, I'm going to give you a number that's already in decimal notation. Ooh, no, I'm going to give you one in scientific notation, sorry. We're going to go 8.46 times 10 to the negative 5th power. Okay, translate both of those things. Pause the video. Alright, we're back. Check in, see how these went. 1.36 times 10 to the 9th power. 9 was 9 swoops to the end. And down here, 0.0000, that's 4 zeros. 846, because you swooped to the left 5 times. So there's a little quick review on scientific notation. Changing subjects again. Make a little heading up there. Only got about 2 more hours for this video, so hang in there. No, not that one. Just a few more minutes. 2 more little quick topics. Exponents. If I've got an exponent, like 6 to the 2nd power, what does that mean? Well, remember, exponents are a shortcut for multiplication. That's really a 6 times 6, which remembers 36. So if you're seeing an exponent, just write the word multiplication down next to that. It's repeated, maybe we'll stick repeated, that makes better sense. Repeated multiplications. So 5 to the 3rd power is going to be 5 times 5 times 5, 3 times. Second heading, fractions. We've learned how to do all 4 types of things with fractions this year. When we add and subtract, just jot down, you need a common denominator. Right? And the best way to do that is by multiplying the 2 current denominators to get the common denominator. When we multiply fractions, that's the best part of working with fractions. You just multiply across, top times top, bottom times bottom, simplify. And then when you divide fractions, remember the words we used were copy dot flop. You're basically just turning it into a multiplication problem. Copy dot flop all the way through that one. So a little quick fraction review. They're going to pop up on your little packet as well. But I just want you to get those notes down in that framework down there for those fractional problems. Alright, we're going to stop there with number sense. There's a whole lot more we can talk about and a whole lot more you're going to see in your packet. But that kind of gives you a good framework to start off with. Alright, so I'm going to stop here and break out and do some practice.